Hey guys, and welcome to this new class in flight instruments. In this case, what we will do is study how instruments based on pressure work. Right, so first of all, what we need to know for those instruments which work based on information gathered by pressure is that we have two types of pressure to take into account. The first type of pressure is what is known as static pressure, and the second one is the dynamic or Pitot pressure. Right, so the static pressure would be the pressure that you perceive at a certain point. Like if you are standing at sea level, you will perceive one specific, the pressure will be that which is derived from the atmospheric pressure that you have above you. However, if you are climbing a mountain and you're 3,000 meters up, at that point you will perceive a different static pressure. The dynamic pressure, however, is also related to the static pressure, but takes into account the velocity, the energy of a specific flow due to the fact that it has a certain velocity. So in aircraft you can easily perceive that the static pressure can be obtained, but also the dynamic pressure can be obtained, and it will be bigger because of the fact that we are moving at a certain speed. The aircraft is moving at a certain speed, okay? So the basic definition of static pressure we already took into account. For an ideal gas and how it's studied in fluid dynamics, we simply define this pressure as this expression over here, okay, which is the density and temperature multiplied by a constant. Okay, and the dynamic pressure, which is the main difference between, the velocity and the static pressure, just takes into account that the total pressure or dynamic pressure will be the static pressure plus this component over here, which depends on the square of the velocity of the flow. So easily, as we mentioned before, the static pressure will depend on the altitude that we are on, whereas the total pressure will depend on the altitude but also on the velocity of the flow. So clearly the dynamic pressure will be very noticeable in aircraft. Right. So a bit of what we mentioned already, let's put it in an example, a visual example of how this works. So in this case over here, in which we don't have any flow, we can easily define that we will be having a specific static pressure over here, okay? I defined this liquid in green color as a liquid that we have, as a manometer, right? So the idea is that by having a hole over here and having a hole over here, we will be perceiving the same static pressure because there's no velocity. Okay, velocity is 0, and if we go to what we were defining before, if velocity is 0, this component over here is 0, so the static and total pressure become the same. Okay, right. What happens if we actually accelerate the flow? Okay, or rather we accelerate the aircraft, then we will be perceiving a static pressure on this part over here because of the fact that the air which is going inside is moving perpendicular to the flow. Okay, this is an important part. Whereas, and in this case, if we have this pipe which is allows for the flow to just go in, move in, due continuity of the mass, we will actually perceive this pressure on this part of this liquid that we defined initially, right? So what happens? Well, the pressure on this part against the pressure on this part will be different. So there's a balance in altitude, okay? There's a difference in the altitude of the fluid because of the fact that the fluid starts moving in this direction, and therefore there's more fluid on this part, so there's an additional gravitational part due to the additional mass, okay, of the fluid that we have, which summed with the static pressure becomes more or less the same. It should be in fact exactly the same as the dynamic pressure that we're perceiving on the other side, right? So this is the basic thing that you need to take into account. The increase in the altitude, okay, or the difference or the way in which the fluid is moving from one side to the other determines the difference between the dynamic pressure and the static pressure. And so this H can be easily related to the velocity of the flow. This is the key point, okay? As I mentioned, this is just to remember the parameters: static, okay, the dynamic, and finally the fluid weight, the additional fluid weight, because of the fact that we're moving the fluid, which is perceived as an additional pressure, okay, an additional force, which goes balanced with the dynamic. Right. In general terms, in aircraft today, what we use is what we call a Pitot tube, which was developed many years ago as a key tool to perceive the dynamic pressure and to be able to compare it then later with a static pressure. Now, the most basic configuration is the simple Pitot tube, which only has one chamber coming inside like this, which is, as we mentioned, parallel or in the same direction as the flow. Okay, so by using this Pitot tube, we are able to determine the dynamic pressure, right? Instead, if we use a static source, that would be by closing the initial part that we have over here and actually putting a couple of holes over here in a perpendicular direction to the respect to the flow, what we are getting is a static source. Okay, so we could actually define some kind of geometry like this, but getting only the static pressure. And in the main case, okay, that is actually used is using the Pitot static tube, which is basically the combination of both, right? So making a couple of holes like this to get a Pitot, to get the static pressure, and also having a hole over here to get the dynamic pressure. And then by comparing one to the other, we can get the velocity of the aircraft, for instance. Right, so as you can see, this is a Cessna model with a Pitot tube. It's always in this kind of L-shaped, okay? Usually it's this L-shaped, except for the cases of fighters, for instance, which you probably have seen that we have this element on the front, on the very front of on the nose of the aircraft. This is usually a Pitot tube, okay, to determine the velocity of the flow. This is another example of the Pitot tube, what it looks like from closer up. And these are some examples also from Pitot tubes used on our Airbus A350. Okay, so without further ado, we can now study more deeply the different kind of flight instruments.